greener strategy to tune the physico-chemical properties of materials. To begin with, I would like to tell that that polymorphism is not just a chemical concept. Rather, we can see polymorphism all around us in our environment. To prove my statement, I would like to drag your attention to the first picture where we have three little birds like parrot. So you can see that they are of the same species. Means everything is similar, but the only difference we can find out is the color, the change in the color near that neck region. One is having orange, one is having red, and another is having black. So here we can see that even though they are of the same species, they are differentiated by slight physical appearance. So here we get the nature itself gives the evidence of polymorphism, which tells us that even though we are taking anything that is of same species, due to different in the physical appearance or physical properties, each of them can be differentiated from each other. So these three parrots are differentiated from each other. Everyone is a single individual. So coming to the concept of chemistry, I would like to tell that polymorphism is the ability of a material, mostly solid materials, which can have or which can exist in more than one single crystalline form due to the change in their molecular arrangement, and they have different physical properties. But mind it, they have the same chemical composition. We are not changing the chemical composition, only the physical property is differentiated from each other. So my research work is totally based on the compound that is BPBA, that is 4-bromo-phenyl boronic acid. And why I have chosen this compound? Because from the previous literature survey, we have figured out that it has versatile application in different fields. For example, pharmacy, agriculture, and synthesis of organic LED and different functional materials. But the thing which we are more focused on is their major drawback. That is, it has low water solubility. Means it is less soluble in water, but more soluble in organic solvents. That's why we are focusing on this material. And our main priority is to enhance its water solubility. For that, we have considered For that, we have considered several methods of crystallization, but this method gave us the successful result. Here you can see this is a highly resolved microscopic image, that is form 1 of the pure parent form of BPBA, and we have taken solvent with it to mix it, and we kept it under reflux in the condenser at heat and stir process for 60 at 60 degrees Celsius for 4 hours. And when we figure out that a transparent, here we can see it's a transparent solution was formed, then we filtered it out and kept for evaporation, and it was a slow evaporation method. It took 2 to 3 days at room temperature, and finally we got the crystal. Here you can see the transparent crystals we have formed, and when we saw it in microscope, we got to see that the parent form, this is the form 1, is different, having different crystal structure than form 2. So to prove or to check whether we have discovered a new form of BPBA, we have done several characterization methods. Starting with we can check PXRD. So here we have done powder XRD, and we can clearly see that we are getting different diffraction peaks. The pattern is totally different from each other in form 1 and form 2, which signifies that the newly generated form, the crystal, is different from the earlier, the parent form of BPBA. And second, when we conducted XRD, single crystal XRD,
y axis एक्सरसाइज कौन करेगा? छाड़ दीजिए।
ଆଜ୍ଞା
वही एक्सरसाइज जो 12 लगे